Hey awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So welcome back. Jadi dalam video kali ini kita akan sambung chapter 2. Jadi sebelum tu sekiranya you berminat untuk tengok video-video chapter 2 yang lama ataupun short notes animation, awak boleh pergi dekat sini folder chapter 2 kinematics of linear motion. Tekan dekat sini. Okay, lepas tu nanti dekat sini ada short notes animation untuk projectile motion, and then we have linear motion graph, ataupun you boleh tengok pada ini kita ada video untuk nota berkaitan dengan projectile motion dan juga kinematics of linear motions. Okay, dan dalam sini pula kita juga ada extra question, jadi awak boleh tengok lah. Okay, so jom kita mulakan untuk discuss soalan modul yang terdapat dalam chapter 2. Alright, so jom kita mulakan dengan subtopik 2.1 about linear motion. Jadi dalam kotak ni kita ada definition, equations and also units. Okay, for instantaneous velocity, average velocity, uniform velocity dan juga acceleration. Jadi yang ni kalau boleh you hafal dan tolong ingat. Okay, so jom kita tengok dekat bawah ni. First kali adalah instantaneous velocity. Secara mudahnya, instantaneous velocity ni adalah velocity pada ketika itu. Velocity at a specific position or instant of time. Pada ketika itu, pada keadaan itu. Okay, jadi kalau kita nak tulis dia punya definition, okay, awak pastikan awak lengkapkanlah dekat sini. Okay, velocity at a specified position. Sorry ya, tulisan saya buruk sikit sebab pen saya ni dah patah. Or instant of time. Contoh, what is the velocity at t equal to 3 second? Macam tu. So, pada ketika itu, apa velocity dia? Ataupun apa velocity dia pada point A, pada point B? Okay? Instant of time along the path of the motion. Ataupun the path of motion. Okay. And then the formula. Okay. So, kita akan tulis. So, kalau kita nampak begini, that's mean this is about instantaneous velocity. Okay. Alright. So, delta S, the change of displacement over time. And it is equal to ds over dt. Okay. ds over dt is the differentiation of equation of displacement. Okay. Contoh, you ada S, equation displacement. S is equal to 2t squared plus 4t. So we want to determine what is the instantaneous velocity at t is equal to 3 seconds, for example. So you need to differentiate. Alright, you need to differentiate d over dt. Ataupun kita tulis kat sini v is equal to ds over dt and it is equal to d dt. The equation of s is 2t squared plus 4t. Okay, so kita akan dapat equation v where v is equal to 4t plus 4. Therefore, the instantaneous velocity at t is equal to 3 seconds. V is equal to 4 times 3 plus 4 and v is equal to 16 meter per second. Okay, so kita tahu macam tu lah. Macam mana kita nak kira instantaneous velocity. And then the unit is meter per second. So this is meter per second. Sama juga average velocity, meter per second. Uniform velocity, meter per second. Okay, apa beza tadi? Instantaneous velocity adalah velocity ketika itu. Pada keadaan itu. Pada waktu itu. Tapi average velocity, dia ada perkataan rate. Rate of change. Okay. Change apa? Change of displacement. Bukan change of distance. Definition dia kena betul. Rate of change of displacement. Okay. Sebab ini adalah velocity. That mean dia adalah, okay. Saya tulis macam ni lah. Dia adalah change of displacement over change of time. Okay. Sebab apa? Ada perkataan rate tu. So, rate tu maknanya kita kena bahagi dengan perubahan masa dia. Okay. So, dia adalah equal to S final minus S initial over T final minus T initial. Boleh? Okay. And then uniform velocity. Kalau soalan sebut uniform velocity, bermaksud objek itu sedang bergerak dengan keadaan dia adalah, velocity dia adalah constant. Bila velocity dia constant, maknanya velocity dia tidak berubah. Sama ada dia punya magnitude dia tidak berubah ataupun direction dia tidak berubah. Okay, so ayat dia adalah uniform velocity ni adalah motion. The motion of the object. Okay. Saya tukar warna hitam. Okay, motion. Okay, motion with constant. Constant velocity. Okay. Is the motion that does not change in speed. Speed tu adalah nilai halaju dia. Ataupun direction. Kenapa ada perkataan direction? Sebab kita cerita pasal velocity. So, motion with constant velocity adalah is the motion, so kita kena faham is the motion of an object yang tak ada perubahan speed ataupun direction. Okay, it's the motion that does not change, sekejap ya, change in speed, nor direction. Salah satu ni, dua-dua ni mesti tidak berubah. Dia tak boleh salah satu berubah. Kalau speed dia, contoh objek itu bergerak ke kanan, kan? Kita tahu speed dia adalah 10 meter per second. Lepas tu dia patah balik ke kiri. Ini ada perubahan. Velocity dia akan jadi negative 10 meter per second because of the direction is to the left. Jadi walaupun dia punya speed dia constant, tapi dia punya pergerakan dia berubah arah, change of direction, kita tak kata uniform velocity. Okay, nilai or halaju dia, speed dia constant, sama. Tapi sebab direction dia berubah, so dia ada negative. Okay, direction to the left. Okay, jadi V constant, apa yang kita perlu ingat? Okay, V constant, acceleration mesti equal to 0. Kenapa? V constant, acceleration is equal to 0. Okay, nanti kita akan tengok graf sekejap lagi. Boleh Okay, kalau instantaneous acceleration sama. Dia adalah acceleration at that time, at a particular instant of time. So, kita tulis dekat sini, acceleration. Apa acceleration ketika itu? Pada waktu itu. At a particular instant of time. Okay. Jadi kalau kita tulis, kita nampak macam ini, maknanya kita nak differentiate. Okay. So we have, this is the change of V over delta T lah. So kita akan dapat differentiate equation dV over dt. Okay, sama macam tadi. Kalau you ada equation V, let's say this is equation V, iaitu 4t plus 4, and then you want to find what is the acceleration, then you can differentiate. Okay, the unit is meter per second squared. Meter per second squared for the average acceleration, and meter per second squared for the uniform acceleration. So definition ni awak lengkapkan lah, supaya senang you nak study balik. Average acceleration mesti sama. Dia ada perkataan rate change of what? Okay, rate change of what? The rate at which, an object, is changing its velocity, at a specific instant of time. Okay, so how to calculate average acceleration. Okay, so delta V over delta T, Maknanya V final tolak V initial over T final minus T initial. Okay, so ini beza dia. Ada delta T. Boleh Uniform acceleration maknanya acceleration ni tidak berubah. Maknanya uniform acceleration adalah constant acceleration. Okay, constant acceleration. Okay, ataupun uniform acceleration. Okay, is a constant. Sekejap ya. Ataupun kita panggil dia sebagai constant. Constant acceleration, okay, is acceleration, okay, that does not change. Sorry ya, tulisan saya agak ni sikit sebab pen saya dah patah ni. That does not change in time. Okay. Jadi kalau kita tulis, okay, pada ketika ini, constant acceleration means that A is equal to dV over dt ni, A itu constant. Faham ya? Kalau A constant, bukan V equal to 0. Okay, V is not equal to 0. Ada nilai. Okay, ingat ya. A constant, V is not equal to 0. Faham? Tapi kalau V constant, yes, A equal to 0. Tapi kalau A adalah constant, remember, V is not, okay, not equal, sekejap ya. Okay, equal to 0. Ataupun kita kata V is not equal to 0. Boleh. Okay. Okay, so now let's look at 2.1b. So this is the basic graph of displacement. Okay, you can see here. Sekejap ya. Okay, so this is the basic graph. So we have 3 types of graph that you must know how to interpret the motion of the object. The first one is when displacement against t, velocity against t, and acceleration against t. Alright, now look at here. Okay, if we put a number here, 0, let's say this is 10. So from 0, let's say from 0 to 4 seconds, what happened to the object? You can see here, this is the horizontal straight line. Means that dalam masa 4 second, objek itu static. Sebab ini graph S against T. Position of the object is not changing. Dalam masa 4 saat, dia duduk pada keadaan 10 meter. So kita kata apa? Object is at, apa dia? Object is at rest. Ataupun kita kata static. Ataupun kita kata stationary. Tidak bergerak. Jadi kalau objek itu tidak bergerak, automatically V dia kosong. Dia tidak bergerak. It's not moving. Okay. So when we sketch a graph, okay, daripada sini, we want to change. Okay. Graph V against T. Sorry, the motion from S against T to V against T. Sebab kita dah tahu, dalam masa 4 saat tadi dia berehat, dia tidak bergerak. So from 0 to 4, so the reading here, the value is 0 meter per second. Ingat. Okay. So velocity is 0. Velocity is 0. Okay. Ataupun tulis kat sini lah, V equal to 0 meter per second. And then kalau dah tak bergerak, so automatically acceleration dia pun 0. Okay. So acceleration is also 0. So kita tulis dekat sini. So kena faham this is all the concepts that you must know and you must understand, okay, in order to solve the problem of displacement against time graph, VT graph, and also AT graph. Okay, so this one you can write A is equal to 0 meter per second squared. Okay, so let's move to the next part. Okay, now you can see this is the graph of S against T. So daripada masa dia 0 sampai 4 second. Okay. So maknanya, start from here. So, semakin lama semakin meningkat dia punya nilai S. Increasing in displacement in positive direction. Ingat, macam mana saya tahu dia positif? Sebab nilai S saya increasing and nilai S saya adalah positive value. Okay, so saya tahu objek itu sedang bergerak, okay, to the right. Let's say start from here, this is the starting point. Okay, so it's moving to the right. Okay, dia berhenti dekat sini. Contoh. So daripada 0 meter sampai 10 meter dalam masa 4 second. Dia bergerak ke kanan. Okay, sebab saya punya nilai S saya adalah positive 10 meter. Okay, so this is direction. Direction of the motion of the object is to the right. So object is moving in positive direction. Ataupun kita kata moving in forward direction, ke depan. Dia bukan moving backward. Okay. Boleh Okay. Jadi, bila kita ada graph S against T, okay, a straight line graph, you can calculate the gradient of the graph. Okay, daripada graph displacement against time, okay, if you calculate the gradient of the graph, so it will give you velocity of the motion. Okay, and then kalau you ada graph velocity against time, you kira pula dia punya gradient, dia akan bagi you nilai acceleration of the motion of the object. Okay, jadi you tengok dekat sini. Kalau saya ada nilai, okay, from 0 to 4 seconds, saya tahu objek itu sedang bergerak to the right. Okay, it's moving to the right. Okay, so when we calculate what is the gradient, boleh kira tak gradient dia? Boleh. Dan bila kita nampak dekat sini, bila kita lukis triangle for the straight line graph, okay, at any point of the graph, the gradient is constant. Maknanya kecerunan dia sama. Contoh, pada point A, point B, point C, sama. Kecerunan dia adalah sama, constant, malar. Okay, so kita tahu bila kita kira gradient, is equal to y2 minus y1 over x2 over x1. Kita mau kira y2 is 10, y final. Okay, sekejap saya tulis saya equation. y1 over x2 minus x1. So y2 is the final coordinate of y. So 10. 10 minus 0 over 4 minus 0. So it's equal to 2.5 meter per second. Okay, so this is actually the value of the velocity, the constant velocity, 2.5. Okay, so kalau saya nak sketch graph V against T, so sini 0. Dalam masa 4 second, objek itu bergerak ke arah kanan to the positive direction with constant velocity. Berapa nilai velocity dia? 2.5. So the velocity is constant. Okay. And you can see here, this is positive value. V is positive value. Means that the object is moving to the right. Because V is equal to positive 2.5 meter per second. And it is constant. Okay. Positif. Positif menunjukkan dia bergerak ke kanan lah. Okay. Jadi kalau you tengok graph V against T ni, dia adalah straight line graph. Horizontal straight line graph. Here. So tak boleh kira pun gradient. Tak boleh kira pun kecerunan graph. Therefore, the gradient of the graph M is equal to 0. So, bila kita nak tulis, kita tahu dah tadi, when V is constant, tak kisahlah constant bergerak ke kanan ataupun ke kiri, automatically acceleration is equal to 0 meter per second squared. So, from 0 to 4 second, okay, acceleration dia kosong lah. Acceleration is 0, where A is equal to 0 meter per second squared. Boleh Okay. Okay, next. Graph S against T here. You can see from 0 to 4 second. Masa 0 second, objek itu berada pada 10 meter. Semakin lama berkurang. 10, 9, 8, 8, 7, 6, 5, 4, 3, 2. Sampai masa after 4 second, dia dah berada pada 0 meter. Okay, dia maksudnya macam ni lah. Tadi contohlah. Contohnya, this is the starting point. Okay, so this is at 10 meter, right? So means that the object is moving to the left, patah balik. 8, 7, 6, 5, 4, 3, 2, 1, 0. So, means that object is moving in negative direction. Atau kita kata dia moving in opposite direction. Ataupun kita kata dia moving in backward direction. Patah balik. Kalau you perasan, okay, kalau pattern graf macam ini, ni saya punya pen ni rosak ni. Graf saya macam ni dengan macam ini. So, ini kita panggil dia apa? Positive gradient. Ini adalah negative gradient. Kan? Jadi, kalau kita kira the gradient of the graph, when you calculate here, the gradient should be equal to negative 2.5 meter per second. Kenapa ada negative? Because the motion, the object is moving backward. Ataupun dia patah baliklah, moving in opposite direction ataupun kita kata backward. So negative 2.5. So in 4 second. Okay. So sini adalah negative 2.5. Okay. Tapi constant tak velocity dia? Constant. Velocity dia negative 2.5 meter per second. Tapi dalam masa 4 saat, dia tidak bertambah pun. Okay. Bila kita kira kecerunan dia ni, graph straight line, kecerunan dia constant, sama. So, V dia adalah constant. Okay. So, kita boleh tulis kat sini, velocity is constant. Okay. And velocity is negative value. Kalau kita ada nilai, kita tulislah velocity kita adalah negative 2.5 meter per second. Boleh? And boleh kira ke kecerunan graph S against T? Tak boleh. Sebab, ni silap ni awak betulkan kat sini. Ini V against T. Meter per second. Okay, correction kat situ. Okay, so kecerunan dia tak boleh kira. This is zero. Zero gradient. Okay, so bila zero gradient, means that acceleration is equal to 0 meter per second squared since the velocity is constant. Kan? So, acceleration dia adalah 0. Boleh? Okay. So, saya rasa untuk video ini, okay, iaitu subtopik 2.1a and 2.1b. So, saya stop dekat sini. Okay, so for the next video, I will continue with 2.1c. Okay, how to solve question and how to determine the distance travel, displacement, velocity, acceleration from the graph given. Okay, see you in the next video. Assalamualaikum. Bye-bye.